I got it working this morning, and it'll get intermittently if I plug things in and restart it just right, but it doesn't stay connected. I can't explain it. The computer just decides, no, I've had enough. Forget that monitor, and it just stops. And it's driving me bonkers. Which means I have no sound. You're going to have to respond, type it up in chat, and then you here in the room will need to join the Zoom if you want to be able to see what I am talking about. Otherwise, good afternoon, everybody. We can begin here, and we're going to start with last week's exercises, the 1.8 practice. Let's see how your drawings turned out. Okay, they should look something pretty similar to mine. The main features being, of course, this guy is all rectangles, although in order to draw three-dimensional rectangles, we draw two-dimensional parallelograms. Don't let that throw you off too much. Just like 3D circles are represented by 2D ellipses. All right. This guy is a square prism, or square base prism, because you have the two squares here connected by rectangles. This one has two pentagons connected by rectangles, so it's a pentagonal prism. Number 5, slicing that cylinder will give you a rectangle. Slicing the cone that way will give you a triangle. Both of those, if you sliced it the other way, you'd be left with circles. Then down here, number 7, this prism is made up of 4 by 3 by 4, so 48 total tiny little cubes. And on the very front, I can see 12 of them here. I can see 12 more on this side. Careful not to count these squares again. These squares are attached to these squares, so I've already counted those cubes. Similarly, I've already counted this bottom row and this bottom row, so there's only 6 more on the bottom here. So I can see a total of 30 right now, which means there are 18 hidden on the back side and in the middle there. And then number 8, we know that this block is 4 tall total. This much is 2, so that leaves 2 left down here for x. And if we transfer this 4, we know it's 4 all the way across, but it's 3 up here, so this extra bit down there must be 1. So some transfers across the shape and then subtraction to get those. Does anyone have any further questions on these exercises? No? Okay. Then let's turn to today's material. We are going to begin by reviewing your notes. So for section 2.5, there were 2 main conjectures, right? Dealing with the angle relationships. Okay? There's 2 different ways of describing angle relationships. You can talk about the configuration of the angles, how they are drawn there. So one configuration would be to create that angle pair, the linear pair. And that is any 2 angles here that compose a single line, right? We've got the line across there, and those 2 angles form that whole line. So they are configured as a linear pair. And then that configuration, we can deduce something about their measurements. How do the measurements compare? And if you were to get out your protractor and measure a whole bunch of linear pairs, you check this one, and you check this one, and you check that one, you'd start to develop a pattern, right? Use that inductive reasoning. Every linear pair I've measured so far, they always do this. So I'm going to conjecture, I bet every linear pair does that. So right now it's a conjecture because we've used inductive reasoning to come to this conclusion. We haven't proven with absolute certainty yet. We haven't used the deductive side. Okay? We'll see that done later. We'll get back to it. But right now, it's more expedient if we just go with our gut. What does it look like they're doing every time? Turns out geometry is very favorable towards most people's gut feelings. If you were to use one word to describe the relationship of the measures, if the angles are a linear pair, how do their measures compare? Are the measures the same and the angles are congruent? Do the measures add up to 90 degrees and they are complementary? Or do the measures add up to 180 degrees and the angles are supplementary? This will always be our three words to use to describe angle-measure relationships. Okay? Anytime you ask, hey, what's the relationship between these angles? If they're implying the measurements, it's going to be one of these words. If they're talking about how it's configured, how is it drawn on the page, then it's going to be one of those other terms such as a linear pair or the vertical angles or alternate interior, right? That's a configuration. This has to do with measurements. So, hopefully, you've completed your investigations this weekend. As part of completing your notes, you need to figure out what is supposed to go in each of these blanks. So the book had you drawing stuff. If you followed those directions, you would have sketched things out on paper, maybe taken one paper, held it on top of the other, and like looked through, especially if you have some tracing paper or some wax paper or something to see through. You could really lay one on top of each other and say, oh yeah, they compare like this. I can see that very directly. Or I provided a link for some digital tools if you wanted to play with those and see how the relationship compares. But either way, you came up with something. So I want to know, tell me in chat right now, what do you think goes here for conjecture number one? If two angles form a linear pair, then they are what? Which word would you use to describe them then? I've got one vote in. Get some more. Thank you, Esme. I've got 2 votes in. They're conflicting votes too. Ooh, it's a tie. I need at least a third one. And there's one for the other third. Okay, we've got one vote for all 3 possibilities. Fatima says adjacent. You're technically not wrong. They are in fact adjacent as well. These 2 angles would qualify as adjacent angles. But we want to compare their measurements. Adjacent doesn't tell us any more about the measures. I want one of these 3 terms. What do you think? That would be like a conjecture 1/2. All linear pairs are also adjacent angles. That is true as well. Got another vote for congruent. All right. I can't make any decisive conclusions about what something is based on a picture, but I can eliminate possibilities from the picture if there's no conflicting information. I haven't marked these angles as congruent. Doesn't mean they're necessarily not. But the way they're drawn, one of them is obtuse and one of them is acute. Is there any way that those could be congruent that way? No, you can't have an obtuse and an acute be congruent. So it's not congruent. Next question. This is a full straight line all the way around. A full straight angle is how many degrees? That's 180. So these 2 combined, they should add up to 180. And our word for adding to 180 is supplementary. Turns out supplementary is going to be a lot more common of a relationship than complementary. Keep that in mind until we get to right triangles. Okay? So these ones will always be supplementary. Now what about vertical angles? Vertical angles, remember, are across from an intersection. If I have two lines intersect, I'm talking about this guy and this guy. Opposite sides of the intersection, catty corner from one another, not adjacent. Okay? What's going to be the relationship based on the measures of these angles? And watch what happens, because it must always be true no matter how the lines intersect. So take a look at that left side and the right side angle as I move my line. I can move it here, make both angles really small. I can move it over here and make both angles pretty big. How would you describe the relationship of those measures there? Congruent, complementary, or supplementary? Well, I'm getting lots of votes in now. Any more? Oh, very good. Yeah, everybody's correct so far. Congruent. Two angles are vertical, then they are congruent. You can write that word out, or we have a handy-dandy little symbol for it, which I'll be using from now on. They are congruent. So automatically, anytime you spot one angle across the intersection of another, you know those measurements are going to match. And anytime you spot two adjacent angles that form a complete straight line, you know those two are supplementary. Subtract one from 180 to find the other. Those two tools will let you answer all of the questions up here. Okay? Your exercises for today is to complete and answer all of these questions. Right? So, for example, these two angles are across the intersection. They are, by the way it's drawn, vertical angles. And thus, we know their measurements from that. I won't say it for you, I'm not going to spoil it. B and C are on this perfectly flat straight line. B and C are a linear pair. So if you find the angle for B, you can determine the measure for C, right? Based on that information. See how that works? And you can fill in everything from there. They tell you that these two are congruent, so make use of that. It's kind of like a Sudoku puzzle, in a way, in that they give you just a couple pieces of information, but you know enough about the relationships that you can fill in the rest of it from there. Okay? There's almost always going to be one of these on the SAT. Although, the SAT really likes bringing in the parallel lines for its angle measure questions. So, for today, I'm going to also cover the parallel line conjectures from section 2.6, so flip to that section in your notes. And then tomorrow, we will have more time to actually practice with those types of exercises. All right, parallel line conjectures here. First up, we have the corresponding angles conjecture. So first off, you got to understand, what are corresponding angles? The corresponding angles in any set of lines, I'm just going to draw an alternate picture here. What if we didn't have parallel lines? That's okay. Corresponding angles, alternate interior, all of these still exist. Okay? They have to do with where the angles are positioned. So the corresponding angles are in the same corner. Okay? Corresponding corner, I would emphasize that, C-O-R, same corner there. So from this intersection, this is the upper right-hand corner. From this intersection, I have the upper right-hand corner. These are corresponding angles. Okay? Over here, I also have upper right-hand corner, still corresponding angles. I could also talk about this guy and this guy, upper left-hand corners. They are corresponding angles as well. So no matter how it's drawn, I can still find corresponding angles. But even better, if the two lines are parallel, then something else is true about those corresponding angles. How would you describe their measures there? Take a look at the picture and make your best guess. Type it in the chat. Congruent, complementary, or supplementary? I'm going to erase my diagram. Just the parallel ones. If they're parallel, what is true about the angle measures? Couple votes for complementary again. Careful. Complementary means they're going to add to 90 degrees. Remember, this angle and this angle are corresponding. They're both obtuse. One of them by itself is already over 90, so they can't both add to 90. They're already too big. Fatima's got it. They're going to have to be congruent. I draw two perfectly straight lines, and I have my transversal here. No matter how I stretch it, take a look at that corner. Look at the same corner of both intersections. When one is obtuse, the other is obtuse. When one is acute, the other is acute by the same amount. If I make them one parallel, the other, or perpendicular, right, 90, the other is 90, every time. They're always going to be, that's not a straight line, always be congruent. That's pretty neat, right? You lock that in, make sure these lines are parallel, and then these angles are automatically matching. Very handy. How about alternate interior angles? This is a fun one, because these are the Z angles. Look at those two there, 3 and 6. If I was to trace the lines there, I make a Z. Alternate interior angles. They are called alternate because they are on different sides of the transversal, alternating sides. Interior angles because they are inside, they are between the two parallel lines, as opposed to the outside up here. They're both inside. What do you think is true? If the lines are parallel, I am guaranteed their measures of the alternate interior angles will be, what do we think this time? Take a look. Use the same diagram. As I change this one, watch for the alternate interior angle. Straight line. Okay, look for that Z. I can still make the Z shape here, but now I have two obtuse angles, right? Yeah, there we go. They are going to be congruent again. Sensing a pattern here, don't you? A lot of congruency. All right, and then finally we have the alternate exterior angles. Again, alternate because they're on opposite sides. So here is my transversal, that's the one line that's crossing multiple lines there. And we've got, here's the left-hand side, here's the right-hand side. So alternate angles. And they're both outside the parallel lines. Here's my parallel lines. It's beyond the outside there. And these ones are, drum roll please, also congruent. If the two lines are parallel, if those two lines are not parallel, we do not automatically get congruent alternate exterior angles. In fact, we've got so many congruent here. Everything came up congruent. Why don't we combine this into one statement? And that's exactly what our book did. It combined parts A, B, and C and said we could just write this all as one idea. Okay? The parallel lines conjecture. Anytime you have parallel lines cut by a transversal, then the corresponding angles are congruent, the alternate interior angles are congruent, and the alternate exterior angles are congruent. All of those will be congruent if the two lines are parallel. And only if the two lines are parallel. If they're not parallel, you know for certain they are not parallel, then you also know for certain those angles will not be congruent. So this is a case where the converse is also true. If I know they're parallel, then they are congruent. I can also go backwards. If I know that pair of angles is congruent, then the lines must be parallel. If you recall from last quarter, the converse of a statement is not automatically logically true by its nature. But it can be true based on the particular situation. And the particular facts of this situation tell us both of them are true. Okay? So not only can we say, hey, these are parallel, thus I can figure out the angles, you could also be given the angles and figure out whether or not the lines are parallel. You can use that as a test for parallelness. In fact, the SAT might have a question like that on it. So, to fill out that converse conjecture, if two lines are cut by a transversal to form pairs of congruent corresponding angles, or congruent alternate interior angles, or congruent alternate exterior angles, then the lines are parallel, right? Or you can write out the whole word, parallel. It works both ways, and we'll play more with that tomorrow. For now, I will leave you with this diagram as an example here. I have drawn these two lines here, and I purposefully did a bad job. They don't look parallel. If you extend both of them, they'll probably intersect, somewhere just off screen, right about there, right? They're pretty slanted. However, despite my sloppy drawing, I have said that from the transversal, this is 37 degrees, and this is 37 degrees. And if you believe that, then you would know, because this is, hey, there's that Z shape. These are alternate interior angles, and they're written with the same measure, so they are congruent. If the alternate interior angles are congruent, therefore I can conclude the lines must be parallel. Right? That's a valid conclusion, even though my drawing is sloppy, right? Your drawings can't always be perfect. You're whipping up a quick sketch. You're on the job site. You don't have all your drafting tools with you. You're in a hurry. Don't stop and make them look perfectly parallel. Give some measurements there, and then you can be sure they have to be parallel. All right, any questions there? All right, then I leave you with the rest of the period to work and finish those questions 1 through 15 it was on that worksheet. Again, those are just with the angle relationships. We'll add the parallel line parts tomorrow and mess with those some more. But for now, I leave you with, what do we got, almost 20 minutes to work?